Yes, thank you, Helen. So I will start to share my screen. Let me know if you see slides, if it's okay. Okay.
Yeah, all good.
Then if you will have some questions, I will be happy to answer them. So feel free to get it here. Okay. Yeah, let me get the chat here. Yeah, and I can see it. Also, if I will be too fast, I will not be loud enough. Also, let me know. And okay, I can start. So my name is Irina. I'm senior software engineer at Alvea Technology. And today I want to tell you about integration Cassandra and Solar and why it will be good to integrate it with Kafka. And I will tell you about all features that Cassandra and Solar and Kafka have. So let's start. This presentation is about to give you a brief introduction to Apache Cassandra. And be careful, as it's NoSQL database, you will miss some features that you have in relational database. Then I will give you a brief introduction to Apache Solar. It's a search engine, and you can have full text search when you're using search engine. It's based on Lucene Index. It's also a search engine, and the other competitor of it is Elasticsearch. And I will tell you about Kafka because Kafka is very good to integrate different systems with each other. And before I will start, I want to show you some example where we can use it. This is a business case, and I will call it the problem of tweets. It's about storing tweets in Cassandra. So little history about Cassandra that it was invented basically in Twitter, and they can store tweets in Cassandra, and they can write it very, very fast. And here we can think, okay, we have tweets, but we also want to search on the text that's inside these tweets. For example, we have on this picture 3 tweets. First, Google released new design for icons. Then Apple released new operation system, and then Google released new searching features. And we want to say how many tweets about Google are published, how many tweets about Apple published, and also in Twitters we need to do some verification that it is a good commuter, and we need to check if this information verified, and only then we need to put it in search engine to allow us to search through it. So let's start with Cassandra. It's, as I said, NoSQL database, and it has powerful feature as peer-to-peer architecture. So here you can see that all nodes that store in your information, that working with your information, they are connected between each other with one ring. It's ring architecture, and it allows you do not work with master and slave architecture. So in this case, you don't have any more master and slave, so you don't have single point of failure. It's fault tolerance. If one node goes down, you have data on other node, and you can guarantee high availability. Also, if the node will recurring, it will get data fast. So the time to recovering is minimum. You can guarantee high availability of your system if you're using Cassandra. Then you have data durability because you can replicate your data on several nodes. So you can be sure that even if some nodes goes down from the cluster, you still have the data. Also, you can distribute and replicate data through different data centers. And that allows you to not to lose data even if whole data center is go down. The next thing is elastic scalability. So you can really easily to get up more nodes here. You just add new node and you can have some distribution algorithms that will allow you to work with data fast. How many nodes you want to wait when it will write the data between? You can tune with consistency. So you can tunable performance based on your need. And also it's column narrated and schema-free database. What does it mean? If you want to change the schema of your table, you can do it by adding new column, and it's like free lunch for you because you just add new column and you know that it can exist without migration of data. It's really good if you want to check if you want to change something. And I have questions. How to tune read writes? Yeah, so you just, when you create schema where your tables will be, you say the replication factor. This factor is responsible for how many nodes you will wait for reads or for writes. And you just get this property and you put it in the cluster. And this is how you can tune it. Then you can do some performance tests and see if reads and writes are fast enough or it's not fast enough. If you need it faster, you can sacrifice your writes. You can download your replication factor. So I hope I answered the question. And now, what feature we will miss? So Cassandra, it's no join. You should be really care when you design your data model. When you design your data model for Cassandra, you need to start from queries because don't everything you will have with your queries. In Cassandra, it's different. Forget about joins and you need to denormalization for some tables. And also you need to be really careful about primary keys, about what data should be searchable. Because when you defined primary key for the table, you couldn't change it without data migration. And if your table already really big, like several terabytes, data migration could be too expensive for you. Then the second thing that you don't have subqueries for selecting data. Then you can't use expressions, regular expressions. You can't use like or something else. You can find data only by your keys that you define. Then you don't have transactions, so you can't create a transaction and say, okay, I need this step, this step, this step, and then it's successful, I want to commit it. If something goes wrong, I want to roll bucket. No transactions. Then adding new column, as I said here, we can add new column, but in some cases, it's not possible. For example, if you want new column be primary key. In this case, you need to drop previous table and you need to create a new table with new primary key. So it will not be free lunch in this case. Why? Why is everything designed like this? Well, let's look like how it's working with cluster when client go to Cassandra. A client here is a driver, and one more feature of Cassandra is that it have drivers on several languages, Python, Java, and etc. So you can just get driver into your application, and this driver will provide you connection to the Cassandra. So what's going on when we are working with driver and Cassandra? Driver connect to the node in Cassandra. As we saw here, it's a ring architecture, and it doesn't matter for driver which node will be connected the first. It's connect to any node, and here I said, okay, let's be as example node 4, and this node for now coordinator. And now, if you want to do some queries like, for example, you need to check data on the whole cluster. You can't say, give me data like this on this node. You need to check whole cluster. That means that coordinator will query every node and wait the answer for this node. And it's very expensive. That's why you just don't have this feature in Cassandra. If you want to write or read with some consistency, you can say, I want to read data, and I want to be sure that it's at least 2 nodes that have this data. And if you connect it, it will wait for 2 nodes to make a response from it. Now, you also will miss about the feature if exists. You can't say that I want to insert data even also, I want to insert data in the table only if they exist there, and I want to update data only on some condition. Again, because for this feature, you want to check every node if it exists there or there or there. You don't know where it is exist. You have this syntax in Cassandra, but it's very expensive. Why it's very expensive? This feature called lightweight transactions, and it's funny because it's not about transaction and it's not lightweight at all. Under the hood, Cassandra using Paxos protocol to perform these 2 queries to Cassandra. The first thing is prepare. The leader in Paxos protocol asks replica if they are available to give to change the state. For example, here I want to change the state if the value exists. Yeah, I need to ask replica before if they are ready for it, and they give the promise to the leader. Then leader do the next step, like it's called propose, and it's send the new state to the replica, and the replica should accept the state. And only after leader have accept from all replica, it say, okay, it's finished. We did this lightweight transaction. So in Cassandra, it's even more complex. Paxos protocol, it looks like 4 iteration. First of all, prepare, then promise from replica, then propose from leader and accept from replica, then leader again read from replica, and replica send the result that yes, we set the state here, and the leader commit changes, and the replica gave to leader acknowledge that they committed the changes. And that's why we have 4 round trips across the cluster. And it's too expensive for us. We just can't to have this all. Okay, so suppose you have a good design for your data model and you don't need this feature that you will miss. I have a question here. It doesn't have any master node. Yes. That's an important step, that we don't have slave and master architecture here. With this, as it was, with this no slave and master. That means that you can query every node. It doesn't matter. But when you query the node, and if you have replication factor more than 1, that node that you queried, it's now the leader, and the other nodes that replicate your data, they are replica. And in this case, we have this small coordinations between the node that we queried, not the master node, any node, but we queried one node, and when we query it, it's the next architecture, like leader and replica. How does it deal with network partition? Yeah, the question the question is how does it deal with network partition? So if one node goes down, network some there is Rust protocol for working with recovering partitions. I will not cover it here. And what can I say that if your node goes down, your cluster will still be available. But you know then that your replication factor, you shouldn't define it, you should define it in advance. So you should be guarantee, even if some nodes will not be available, you will not be able to receive them. You still want to do something. And if too many nodes is down, you probably can't write, but you still can read. So you should create enough nodes in your cluster to make consistency do not go down too fast. Because if there doesn't enough nodes to deal with replication factor that you defined, you need to wait until it will be more nodes, until the cluster will be recovered. Well, let's go to the next. Okay. One more question about the network. I will think how correctly to answer it, and I will answer it later. Well, we have the model that good enough, and we need more complex query on your data. As in business case, we need to know how many tweets that contain the word Google exist, or how many tweets with contain 2020 exist, and the answer on it will be Apache Solar. What is it? It is search engine, and it's provide for you full text indexing. It have REST like HTTP API, and you can query with and work with XML or JSON there. Also, you can collect statistic on the fields that you work in these. Also, one of the features that it's well documented, and when people working with Elasticsearch, it's not enough documents, but for Solar, it's really good. And it's have powerful UI. On my next slide, with this UI that you can work this. So you can check what data you have in index, and you just need to install Solar, and it goes with distributive for you. In this example, I say, give me all tweets that have text Google here that contain the word Google. Okay, I search and I can see it. And now we want to have a cluster. And Solar Cloud is open source solution that provide you cluster. And again, it doesn't have peer-to-peer architecture. So you can create different nodes and it's fault tolerance. It has central configuration for the entire cluster, and this configuration in Zookeeper it's automatic load balancing. So if you create Solar Cloud client, you don't have any do anything when you want to query data, when you want to query different nodes. For example, if you use only Solar and the different Solar nodes, you need to use something like balance client, and example is ribbon balance client. Here you can say, I want to use Solar Cloud client, and it will be balanced for you just from the box. That's really cool. And it's also have powerful UI, so you can see what's going on with your nodes, how they load it, are they healthy, and etc. Just from the box. You don't need any other monitoring tools to see at least this information. Okay, I think that's good for me. I can store data in Cassandra. Cassandra will write data very fastly for me. And I want to query complex query, and I see that Solar is okay for me. So how I can say that my data goes to the Solar? And here my solution here is Kafka. So Kafka, it's a one more open source technology, so you can use it for free, and it's have a lot of support and very good community, a lot of documentation, and the main feature that if you bring Kafka in your system, you have event-driven architecture now. So you say, okay, this is event that's happening in my system, and now after you produce this information, you can say that I can have more clients that can consume this information. So the next thing is have Kafka architecture has really high throughput. They achieved it by different hacks, and it's a cluster. That's why it's have you can distribute your data on several brokers, and you have Zookeeper that will manage these brokers, and you can replicate your data so it's fault tolerant. If one broker goes down, you still have interaction in your data. You still have brokers that's available to handle the messages. It have high availability because when broker is recovered, it's quickly get data that missed. It have data durability because it stores data on the disk, And again, you replicate the data, so that's good. You can be sure that data is saved even if one worker goes down. And you can easily add new workers to your system. And one more thing that you can use a lot of consumers. You can scale. You can not only bring more workers, you also can create more partitions in your topics and create more consumers that will pull messages in parallel. So you can increase the speed of how you reading your data really quickly, and it's give you very high throughput because of elastic scalability. And also, if you want to create a client that you can define several instances of this client, the Kafka is good decision again. You just say, I have consumer group, and this consumer group will read a lot of partitions only from one worker, and it will do in parallel. So you can scale your instances like for free, and you can get more throughput. How it's achieved, how fault tolerance and how availability achieved. Again, we have several brokers in the system, and one of the broker will be the leader, and other brokers will be replica. In this example, broker 1, leader for partition 1, and worker 2 and worker 3 are follower. And the same differences for worker 2, it's leader for 2 partitions, and worker 3 is a leader for partition number 2. If worker 3 goes down, zookeeper help to rebalance quickly brokers, and now broker 2 is a leader for partition 0, partition 2, promoted by zookeeper, and partition 3, so your cluster is still available, and it continue to write data and it replicated on broker 1. Final architecture of this integration. So if you have events in your system, it goes to Cassandra, and also you can say that they go to Kafka. They go to Kafka, and this is events that you provide one more component that will index data to Cassandra. Indexer will read this data from Kafka, and for example, check the state of Cassandra if it's valid. If, for example, if it's verified data, and etc., and it's really fast, and then final decision on the data if they should be indexed, it goes to Solar, and now you can really quickly to write to Cassandra. And with eventual consistency, you guarantee that this data goes to Solar, to your search index. And now client can execute complete queries for this data. Feature of the whole system. Again, every this component could be is cluster and it have peer-to-peer architecture, so you don't have single point of failure. And also you can scale this client, you can scale these clients. It is consumer, so you can define several instances of it. And you have fault tolerance system. If one of these instances goes down, you're still good. It's high availability because every component can faster be recovered. Elastic scalability that you can scale everything. You can add more nodes here in Cassandra. You can add more nodes here in Kafka. You can add more instances of your indexer, and you can define more nodes in Solar. It's durability for your data. Every component can store data and doesn't lose it. And it's very fast writes because Cassandra provides you really fast writes, and Kafka also get you really high throughput and its eventual consistency. And you can be sure if you create an event, you will get data in the Solar, and you have absolutely powerful search. And let me from now show you a little bit how to work with it. It sounds like really difficult systems, but I will try to convince you that no. Let's first of all look at Cassandra. And I'm working on Windows, so even on Windows you can work on with all these components. So for Cassandra, you can install it on Windows, and you just type Cassandra and you start the cluster. On one machine, it will be one node cluster. So how to work with it? When you install Cassandra on your Windows machine, you have there the tool that calls SQL SH, and I will exit right now. So this is basically the syntax how to iterate this Cassandra, and it's really similar to SQL. It's really similar, so it's easy to work with it. And let me repeat the steps that I did. I can connect to my Cassandra on my local host. Let's see. Okay. Then I can describe key spaces that I have there. If you see, you have some key spaces that are system key spaces. You can't drop it, but also you can have here your key space, and let's drop it for now and create again this Java application. Oh yeah, drop key space. So for now, let's look at application that will work with it. I will stop it for now. So for this application, I use Spring Boot, and it's really easy. Also, let me know. I think the font is good enough. Let me know if you need something with fonts or something else. So I will create a small Spring Boot application, and I will define tweet repository. The tweet repository is repositories that use Cassandra repository is an interface with Spring Cassandra data framework. And we can say that the table will be tweet and the primary key will be string. We just will use ID as primary key, and we don't need anything else for now. Let's look at tweets. It's a table. It has primary key that you can define with annotation from Spring. So everything basically like Spring data. And also you need to define Cassandra configuration, and it's also let you to create key space just from scratch. You can say which key space you want to create, and yeah, for it you need to override get key space creation and say which key space you want, and you can say what replication, and also you can say what you want to do if applications go down. You can say that you want to drop key spaces. And here I know that configuration will create key space for me, and I want just insert data. So data will be simple, as I showed you. Google released new design for icons, Apple released new operation system, and Google released new search features. Okay, we can insert it. We get this method from Spring Data, and we will print the results, as we have this method just from Spring. So let's try. So as you can see, the application really is small. I have it on my Git repository, so feel free to come and download it if you want to check the examples. Okay, it's finished. It's created tweets. Let's go to the console. Let's say describe key spaces. And we have tweets as key space. Let's use it. We just should say that we want to use this key space. And let's describe tables. So we have one table, and as you see, we just say select everything from tweets. And as I used colors, you can see everything with colors. So we created ID as a unified ID, and we saved our text here. If it will be the same ID for the even different text, it will be just overwrite here. And what else? We can go to this data from IntelliGD. Of course, it has separate. So you need to say that you want to use Cassandra. And it's enough here to say connect to localhost and key space that you want to connect. You also can define user and password to protect your data in Cassandra. Okay, we can connect here. Let's do it. And now let's look at the table. Okay, here we can see data in this table. So IntelliGD give you everything to work with it. Let's go to the next example, to the Solar. So again, Solar as a client exists for Windows, and it's enough to say Solar start, and it will bring Solar server for standard port for you. Let's look how it goes. Let me look at this. Sorry. I can. So I just need to say the localhost and 8983. Okay, this is my powerful UI. So I don't need to install anything, just Solar, and I already have all information to work with it. If something goes wrong, I can see it in logging. All cores that I created, I see it here. The core is the concept that you have data, like key space in Cassandra, it's core in Solar, even like a table, I think. So I created I created the core tweets, and let's go there, and I can query it. I can say, give me everything that's inside this core. Execute this query, and here you can see the ID, the text. Basically, that's everything that we saved there. And now I want to search with expression. Give me everything that contain Google. Okay, and give me everything that contain Apple. Okay, and give me everything that contain 2020. Okay. So how to work with Solar? It's also easy. That's why I will be happy to show it. So here is my Solar test. I hope everything is visible. And I can say that I want to connect to Solar server. It's have a default port. It's on local host, and I will use different collection name. It will be tweet set, and I want to create a new data with new ID. Let's bring something like this. One. Then, how to create a client? You just define the URL that you want to connect to, and you just create a builder. So the Solar have Java APIs that let you use it just by several lines. I think it's amazing. So let's add data. We created the Solar client, and what we need to do, we need to say on this client that we want to add data, and we define collection name and the Solar input document. So we say that our document, for example, contains will contain ID in text and provided example. Let's run it. And there was a question how to push data from Cassandra to Solar. As I said, you can use Kafka for you can publish data that you want to go to Cassandra, that you want to go to Solar. So you can write even one application, but why you need integration with Kafka? Because you want to maintain data, and also the key point that you need to store with different state between Cassandra and Solar, and you shouldn't require Cassandra wait for data go to Solar. This is a key point. You need to store it somewhere before you will be able to say that data goes to Solar. Let me return to this point after I will show the Solar. After I will show everything, I will return to this point and I will repeat it again. So we go to tweets test and we will execute it. Okay, this is our new data. So what next? So as you see, you just code several lines and you already can work with Solar. And yeah, I didn't say you need to commit data. So you need to say that you are ready for new state for collection, and you say that please commit this state. So you can add several documents and only then commit. Then you can query data. It's also very easy. So we just have Solar client. We have to say query for collection. And in this example, I want to say, give me all queries that, all documents that contain Google. Yeah, so I just said with this regular expression. And the result will be, as expected, one document and ID the same that we expected. So we saw it here. Okay, is it here? And also you can delete everything by query or by ID. And it's also just several lines. So let's delete everything and commit this. So we will see that there is no result. Yep. So let's query everything again. Okay, so as you see, it's really simple to work with Solar. And my last example, I will just show several lines with Kafka. It's also have a Java client and it's easy to work with it. You just say that you have Bootstrap services at services for Kafka. So I didn't install it on Windows, but I get the Docker container with Zookeeper and Kafka because with Solar Server you can experiment without Zookeeper, but for Kafka you need Zookeeper. So what you can do, you can just get any example with Docker Compose, define the network for Zookeeper and Kafka, define the services, and that's it. You just get this cluster from Docker. You also can get the cluster on Solar and Zookeeper from Docker. And if you want to work with more DevOps side, you need to work with, you can use the same Zookeeper for Solar and Kafka. That's why also these components, that's really good to use together. So from Java, you just have several lines to work with Kafka. You create Kafka producer. To simplify it, I create the producer that have string as key and it's partition key. And also you can distribute your data in one Kafka broker by several partitions by your key. You can monitor it with, for example, if you use a unified ID for partitioning, it's good because it's distributed. It will give you good distribution for balancing consumers. So data will be in different partitions evenly. So you just say where you want to connect and the topic there you want to send the data. And that's all. And the same for consumer. You just say, you just define that you want to use Kafka consumer, where you want to consume. You can say that you want to consume data from the first data as it published there. And you just get the data by in cycle you subscribe to the topic and you're waiting for the data. So consumer always checks the data and you can notify consumer at any time. It always get updates. And for now, again, why we need Kafka? Yeah, let's go to our architecture again. So we can't say that we want to put data in Solar after we write it in Cassandra, because in this case, we need to create something like transaction in our system. In this transaction, we need to say client, hold on, I am going to do HTTP query to Solar and wait when it will be done. And it's not that it's not that we can let us because we want to really fast writes. So we need something that we can say for, okay, this is some permanent storage for our data. And Kafka is really good because, as I said, you can scale your consumers for Kafka. So you can have extremely fast rates. for massive bunch of data because all they will go to Solr in parallel. You don't need for Cassandra wait for write data inside Cassandra. You store data in Cassandra. And one more thing, you can check the state in Cassandra before putting installer. And it will be fast enough to make a big distributed system with this big bunch of data that requires really fast writing and eventual consistency on searching data. So I hope I showed you that how to work with these components, and I hope you enjoyed. And let me know if you have other questions. Why Kafka instead of DC built-in support for Solar and Cassandra 6? Yeah, I waited for these questions, and I'm so glad that somebody asked it. So yeah, basically, yeah, everything is possible without Kafka, but with data stacks Cassandra. And what will be there? And every node data stacks Cassandra have Solar. It will be on every node. It won't be Solar Cloud. It will be just Solar servers. And if you want to query data, you need to define Solar Balance client. That's not a deal. But what's the problems? If your search index is really big, first of all, you need to create table for this search index. You can't really, it doesn't depend on how you can define your data. It should be the table. Then if you want to update your data, you need to update records on this table. And sometimes you should update really big batch of records. It all depends on design, but it can be really not perfect. And one more thing that data stacks is require the license. And for example, if you bring something for the client that should buy your product, they should buy your license, and also they need to use data stacks because your system defined for data stacks. And that means that you require clients to pay for the license for data stacks, and it made your product more expensive. It's when you don't have time and you have just MVP for your product and you need to check the theory that Solar and Cassandra will work for you, and even just Cassandra will work for you fine. You can try Cassandra and Solar with data stacks, but you need to pay for it. And probably you can't live really long with it because you need your clients pay for data stacks license. So if you want to build your product only on Apache open source technologies, so you doesn't make your product more expensive because of license of other solutions, with this basically decision. I hope I answered these questions. I will be happy to receive more questions. I can also, as I have a little bit more time, I can say how you guarantee that you consume data from the Kafka. Oh, do you mind showing the page containing GitHub? Yes. So I hope it's easy to find me because my GitHub is just Irina. Here I have some notes, and for example, this tutorial, how to put this, how to use Spring Boot, Spring Data, and Cassandra. I will put it in my GitHub pages, Git pages. Also, some notes from this presentation, I have it here, and I have it on Medium, so you can find their information. Okay, one more question. Is it easy to integrate this in Django instead of Solar? I don't know what is this Django, but now I'm really interested in it. And I think, yes, you just create some integration with Kafka. So when you have data that came to Cassandra, you publish it to Kafka. And here you can read it by some consumer and put it to Solar, to Django, to Elasticsearch, everywhere. Kafka right now gives you event source driver architecture. The question, the architecture has events being written to Kafka and Cassandra. Why not to write to Kafka and have two workers reading from Kafka, one writing to Solar and other to Cassandra? Will that increase the write throughput and decouple Cassandra and Solar? The first requirement to the system is to put data in Cassandra. And this system, basically it have a lot of clients that also get data from Cassandra. And Cassandra is really good NoSQL storage. Basically, yes, you can play with architecture more, and you can publish all events. But there is the problem that you need, if you want to guarantee that data goes to Solar, you need to check state in Cassandra. They are not coupled here because you have Cassandra here, you have Solar, and they doesn't matter about each other. But you want data in Solar be consistent with data in Cassandra. So yeah, you can place it, and you can publish data to Kafka, then you can publish it to Cassandra, and then you can publish it to Solar. But before publishing it to Solar, you just need to check that they come to Cassandra. Which point you need to do it in your architecture, this is your decision. Yeah, we will send now. Okay. I see the thank you, and I'm waiting for the questions. And what else I can, as I have time, how we can guarantee that data comes to Solar. One more feature of Kafka, you can say if messages processed. For example, data comes from Kafka, but Solar goes down. It didn't respond for you for some time. And in this case, you little bit stop to read from Kafka. And you can reprocess messages from Kafka by committing messages to Kafka. It's one more feature of Kafka. You can commit that you read message from Kafka only after you did some processing on it. For example, you put it to Solar, you commit that, okay, I'm ready for the next messages. And in this case, you can guarantee eventual consistency in your system. You will not lose messages, even if Solar goes down. Yes, it is right, repo. Yes, Spring Boot. There already is Spring Boot. So you can download it and start to work with it. Yeah, I can include Docker Compose for Cassandra. So Dockers let you to work with the Windows or any other thing.
Any more questions? Otherwise, we can be wrapping up. Oh, there is a question.
Should Cassandra data changes? Should we update Solar as well? Yes, and this happening because Cassandra changes only on events in this system. So if it's create some changes for Cassandra, it's always published to Kafka. So you process with data with indexer. Again, you check that it's true and you put it to the server. Thank you very much. I really like your questions.
Honestly, I haven't seen such a heated conversation ongoing for a while, which means it is a really important and interesting topic. Thank you very much, Irina.
Thank you.
So I guess there are no more questions. To reiterate, we are going to send you in a few days a thank you email with the recording of the event and slides and the links that Irina has mentioned. So if you have any questions, you could get in touch with her. Thank you very much, Irina. This has been really, really, really great talk. Very interesting, very useful. And I believe a lot of people are going to jump into trying stuff right now. So thank you again. Thank you all to all of the attendees for spending this evening with us, and hope to see you soon. And yeah, get in touch if you have any questions, suggestions, anything. We're here. Thank you.
Thank you.
Thank you. Bye.
Thank